بسم الله الرحمن الرحيم.
Assalamu alaikum dear students. I hope you all will be fine and happy. Class 9, subject chemistry, chapter 3, page 83. And today our topic of discussion is electronegativity. Electronegativity. Dear students, electronegativity is a property associated with atoms when they are chemically bonded to each other. Electronegativity is a property associated with atoms, related with atoms when they are chemically bonded to each other. Chemically bonded to each other. Electronegativity is a property associated, related with atoms when these atoms are chemically bonded to each other. Chemically bonded to each other. Dear students, there are four types of chemical bonds: ionic bond, covalent bond, coordinate covalent bond, and metallic bond. There are four types of bonds: ionic, covalent, coordinate, and metallic bonds. And inshallah we will discuss all these types of bonds in next chapter in detail. But here I would like to say something about the second type of bond, which is called covalent bond. Covalent bond. Covalent bond. Covalent bond is a type of chemical bond which is formed by the equal sharing of electrons between the atoms. A type of chemical bond formed by the equal sharing or mutual sharing of electrons between the atoms. A type of chemical bond formed by the equal sharing or mutual sharing of electrons between the atoms is called what? Is called a covalent bond. For example, H2 molecule, hydrogen molecule. So in this case, in formation of H2 molecule, one electron is shared by one hydrogen atom and the other electron is shared by the other hydrogen atoms, and they form what? They form H2 molecule. So you see that in the formation of H2 molecule, each hydrogen atom share one electron. This hydrogen atom share one electron and the other hydrogen atom share one electron. So they equally share electrons and they form a bond which is called what? Which is called covalent bond. This is called covalent bond. Second, for example, Cl2 molecule. So in the formation of Cl2, there are 7 electrons in the last shell of chlorine atom. So they share one electron with each other and they form what? They form covalent bond. Single covalent bond. This is, so they share, each chlorine atom share one electron and the other chlorine also share. So they equally share 2 electrons, single pair of electrons, and they form a bond which is called a covalent bond. So maybe the bond may be formed between the different atoms, may be formed between the same atoms. Here you can see their H2Cl2. These are the atoms of the same element. Covalent bond may be formed between the atoms of the same element, may be formed between the atoms of the different element. Here it is formed, covalent bond is formed between the atoms of the same elements. So similarly, HCl. So in this HCl molecule, one electron is shared by the hydrogen atom and the other is shared by the chlorine atom, and they form a bond which is called a covalent bond. HF. One electron is shared by fluorine and one is shared by chlorine, and they form, it is HCl molecule, it is HF molecule. Water molecule, in the water molecule, oxygen has 6 electrons, so it share its one electron with the hydrogen, and they form a bond which is called a covalent bond. So here you can see HCl share one electron, hydrogen share one electron, fluorine share one electron, hydrogen share one electron. So this type of bond is formed by the equal sharing of electron. In the formation of H2O, one electron, in this there are two single covalent bonds in water. So in this formation, in the formation of this bond, one electron is shared by oxygen atom and the other is by hydrogen atom, and they form covalent bond. In second bond, one electron is shared by oxygen and the other is shared by the hydrogen, and they form other single covalent bond. So this type of bond is formed by the equal sharing of electrons between the same atoms or different atoms. Dear students, this electron, this pair of electron is called shared pair of electrons. This electron which are shared by these atoms are called shared pair of electrons. Shared pair of electrons. Now different atoms have different abilities to attract this shared pair of electrons towards itself. Different atoms have different abilities to attract the shared pair of electrons towards itself in a covalent bond. In the case of these similar atoms, these are similar atoms which are bonded together by a covalent bond. So both have the same ability, both are same hydrogen atom. So in this case, the electron pair is equally attracted to the nuclei of both the atoms. The shared pair of electrons is equally attracted by the nuclei of both the atoms because they are same atoms. They both have the same abilities in the attraction of the electron pair towards itself. In the case of different when different atoms are bonded together, for example HCl, HFO, H2O, so their different atoms are bonded together. Different atoms are bonded together, and they have different abilities to attract the shared pair of electron towards itself in a covalent bond. They have different abilities to attract the shared pair of electron towards itself in a covalent bond, and this ability of attracting the shared pair of electrons towards itself in a covalent bond is called what? Is called electronegativity. So the ability of an atom to attract the shared pair of electrons towards itself in a covalent bond is called electronegativity. The ability of an atom to attract the shared pair of electron towards itself in a covalent bond is called what? Is called electronegativity. In the case of same atoms, their electrons are equally attracted to the nuclei of both the atom. So we say that when similar atoms are bonded to each other, there is no concept of electronegativity. When similar atoms are bonded together, so there is no concept of electronegativity. And in this bond which is formed between the atoms of the same element, this is called non-polar covalent bond. Non-polar covalent bond. The bond between the atoms of the same element is called what? Is called non-polar covalent bond. In this case, different atoms, hydrogen, chlorine, atoms of different elements, atoms of different elements, atoms of different elements, so they have different abilities to attract the electron pair towards itself. In the case of HCl, the HCl do what? It attract the shared pair of electron more towards itself, and due to the storage of electrons, a partial negative charge appears on the chlorine, and due to the shortage of electrons with hydrogen atom, a partial positive charge appears on the hydrogen. So this ability, the electron pair is attracted towards the chlorine atom. The chlorine atom attracted the electron pair towards itself, more towards itself, and this ability of attracting the electron pair towards itself in a covalent bond is called what? Is called electronegativity. Here a fluorine attract the shared pair of electron more towards itself and become partial negative, and hydrogen due to the shortage of electrons becomes partial positive. Here oxygen is more electronegative and attract the electron pair towards itself and it becomes partial negative, and hydrogen due to the shortage of electrons become partial positive. So when same atoms are bonded, the bond is called non-polar covalent bond. But when different atoms are bonded together to each other, so the bond between them is called polar covalent bond. The bond between them is called what bond? What type of bond? Polar covalent bond, because here you can see partial negative and partial positive. Both two poles are here. One is partial positive and the other is a partial negative. So electronegativity is the ability of an atom to attract the shared pair of electrons towards itself in a covalent bond. The ability of an atom to attract the shared pair of electrons towards itself in a covalent bond is called what? This property, this ability is called electronegativity of an atom. Electronegativity of an atom. You can see chlorine attracted the electron pair more towards itself. Fluorine attracted the electron pair more towards itself. In the case of water, oxygen attract the electron pair more towards itself. So this property of attracting the electron pair towards itself in a covalent bond is called what? Is called electronegativity of atoms. Electronegativity of atoms. Now I am coming towards the trends of the electronegativity in the periodic table, that when we move from left to right in the periodic table, what will happen, and when we move from top to bottom in the periodic table, what will happen? Any change, any increase occur in electronegativity values, or a decrease occur in the electronegativity values. Trends of electronegativity in periodic table. So first I am going to discuss the trends in periods. Trends in periods. Dear students, when we move from left to right in the periodic table in periods, when we move from left to right in periods in the periodic table, so what happens? Electronegativity values increases. An increase occur in the electronegativity values of the elements. An increase is observed in the electronegativity values when we move from left to right in the periodic, and when we move from left to right in periods in the periodic table. En electronegativity is represented by E and E for electro and N for negativity. So why an increase occur in electronegativity values when we move from left to right? So when we move from left to right, what happens? Atomic number increases. atomic number increases. And we know that atomic number is the number of electrons or protons. When we move from left to right, what happens? Atomic number increases, and atomic number is the number of electrons or protons. So when we move from left to right, atomic number increases. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, up to argon. So when we move from left to right, atomic number of lithium is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up to 18. So when we move from left to right, you see atomic number increases. Atomic number is the number of electrons or protons. So atomic number increases mean positive charge on the nucleus increases. Suppose this is lithium, whose atomic number is 3, means there are 3 positive charges. Beryllium atomic number is 4, so there are 4 positive charges, 4 protons, and up to fluorine, whose atomic number is 9. So 9 means there are 9 positive charges in the nucleus of fluorine. 9 positive charges. So when we move from left to right, what happens? The atomic number increases, the positive charge on the nucleus increases. When we move from left to right, what happens? The positive charge on the nucleus increases. Atomic number increases mean the positive charge on the nucleus increases. Atomic number 3, 4, and 9. So due to the increase in positive charge on the nucleus, due to the increase in positive charge on the nucleus, the nuclear pull of the nucleus increases. What happens due to the increase of positive charge on the nucleus? The nuclear pull of the nucleus increases. The nuclear pull of the nucleus increases, and it attracts the electrons more towards itself. It attracts the electrons more nearer towards itself, and as a result, what happens? As a result, the size of the atom decreases. A reduction occurs in size. What happens? Reduction occurs in size. Reduction occurs due to increase of nuclear charge, positive charge on the nucleus. What happens? The reduction occurs. The size of an atom decreases. A reduction occurs in size of an atom, and due to the decrease in size of an atom, the ability of an atom to attract the electron towards itself in a covalent bond increases. Due to the reduction in size of an atom, what happens? The ability of an atom to attract the electron pair, to attract the shared pair of electron towards itself in a covalent bond increases, and hence we say that when we move from left to right, electronegativity increases. For example, HF. So atomic number of hydrogen is 1, and here the atomic number of fluorine is 9. So when they form covalent bonds, so the electron pair is more attracted towards the fluorine. Why? Because there is 9 positive charges. There is more nuclear charge in the fluorine atom, in the nucleus of fluorine, and it attracts the electron pair towards itself in a covalent bond. So when we move from left to right in periods, what happens? The atomic number increases, mean positive charge on the nucleus increases, and what happens? Due to the increase of positive charge, nuclear charge, the size of an atom reduces, and due to the reduction in size of an atom, the ability of an atom to attract the electron pair in a covalent bond towards itself increases, and hence electronegativity values increases when we move from left to right in periods. Now trends in groups. Trends in groups. When we move from top to bottom in groups in the periodic table, we move from top to bottom. What happens? Electronegativity values decreases. What happens? Electronegativity values decreases. So why electronegativity values decreases? Why a decrease occur in the electronegativity values when we move from top to bottom in the periodic table in groups? So the reason is that when we move from top to bottom, number of shells increases. Shell after shell is added in each period. For example, group number 7, which contains element fluorine, chlorine, bromine, iodine and startine. Fluorine, chlorine, bromine, iodine and startine. So fluorine is a member of period 2nd, chlorine period 3rd, period 4, period 5 and period 6. Fluorine, group number 7, fluorine is a member of group 7 period 2nd, group 7 period 3rd, group 7 period 4, group 7 period 5, group 7 period 6. So I have already told you that the period number indicates the number of shells. Period number indicates the number of shells. So fluorine is a member of period 2nd, so it means that there are 2 shells with fluorine. There are 2 electronic shells with fluorine. But when we move from top to bottom, so period 3rd, another shell is added, period 4th, another shell will be added. So when we move from left to right, when we move from top to bottom, in groups in the periodic table, number of shells are added in each period. Number of shells increases when we move from top to bottom in the groups, and each shell in each period, one shell is added, due to which what happens? Due to which the atomic radius increases. Due to which what happens? Due to which atomic radius increases. When we move from top to bottom in groups, electronegativity values decreases. Why? Because when we move from top to bottom, shell after shell is added in each period. Shell after shell is added in each period, and due to the addition of shells, what happens? You see the atomic radius increases, and increase occur in the atomic radius. Atomic radius increases. Atomic radius increases, and due to the increasing number of shells, atomic radius increases, shielding effect occurs. Due to the increasing number of shells, the number of inner shell electrons increases. So what happens when we move from top to bottom? Atomic radius increases, and due to the increase in atomic radius, the attraction of the nucleus for the shared pair of electrons in a covalent bond decreases. What happens? When we move from top to bottom, shells increases, due to which the atomic radius increases, because atomic radius is directly proportional to the number of shells. So the number of shells increases means atomic radius increases. Due to the increasing atomic radius, the attraction of the nucleus for the for the shared pair of electrons decreases. What happens? The attraction of the nucleus for the shared pair of electron in a covalent bond decreases, and hence we say that when we move from top to bottom, a decrease occur in the electronegativity values. Electronegativity values decreases in the groups due to the increasing the number of shells. So okay students, it is enough. Now note your homework. Define electronegativity. Second, give reason that why electronegativity decreases. in groups and increases in periods. Increases in periods. Define electronegativity. Question number 1 and second, give reason that why electronegativity decreases in groups and increases in periods. So okay students, wassalam.
اللهم انفعنا بما علمتنا وعلمنا ما ينفعنا وزدنا علما.